Class 9. Subject Science, Physics. Chapter 11. Sound. Topics to be learned in this video: propagation of sound. Propagation of sound. Sound is produced by vibrating objects. The matter or substance through which sound is transmitted is called a medium. It can be solid, liquid or gas. Sound moves through a medium from a point of generation to the listener. When an object vibrates and produces sound, the particles of the medium at the point of generation begin to vibrate. This particle passes on the vibration to its adjacent particle. The first particle comes back to its equilibrium position of rest. Then the second particle passes its vibration to the neighboring third particle, and then again comes back to its position of rest. This process continues until the vibration reaches the listener, and he is able to hear the sound. As we see, the actual particles of the medium don't travel from the point of generation to listener. It is only the vibration that travels through the medium. This is called wave motion. A wave is a disturbance that moves through a medium when the particles of the medium set neighboring particles into motion. Since sound waves are characterized by the motion of particles in the medium, they are mechanical waves. Air is the most common medium through which sound travels. When a vibrating object moves forward, it pushes and compresses the air in front of it, creating a region of high pressure. This region is called a compression, as shown in figure. This compression starts to move away from the vibrating object. When the vibrating object moves backwards, it creates a region of low pressure called rarefaction, as shown in figure. As the object moves back and forth rapidly, a series of compressions and rarefactions is created in the air. These make the sound wave that propagates through the medium. Compression is the region of high pressure and rarefaction is the region of low pressure. Pressure is related to the number of particles of a medium in a given volume. More density of the particles in the medium gives more pressure. Propagation of sound can be visualized as propagation of density variations or pressure variations in the medium. Sound waves are longitudinal waves. A wave in which the particles of the medium vibrate back and forth in the same direction in which the wave is moving is called a longitudinal wave. The sound waves are called longitudinal waves. In these waves, the individual particles of the medium move in a direction parallel to the direction of propagation of the disturbance. Sound simply oscillate back and forth about their position of rest. This is exactly how a sound wave propagates, hence sound waves are longitudinal waves. There is also another type of wave called a transverse wave. In a transverse wave, particles do not oscillate along the direction of wave propagation, but oscillate up and down about their mean position as the wave travels. A transverse wave is the one in which the individual particles of the medium move about their mean positions in a direction perpendicular to the direction of wave propagation. Light is an example of transverse wave. You will come to know more about transverse waves in higher classes. Thanks for watching. Please like and subscribe my channel.